Hello everybody, welcome to my channel. Today I'm going to show you analysis of augmented randomized complete block design using our software, and we will use two packages. The first one is Agricola and the second one is Augmented RCVD. And in addition to this, we will also see about the genetic variability of the model. So the first step to compute analysis of augmented block design is using the Agricola package, and you should have to run this one. And for sake of this tutorial, I already imported my data, and my data name is AUGG, and it's contained, the first is block, the second is treatment, and the last three columns are the response variable. Here is page planted, green yield, and age is above ground biomass. So in order to compute analysis of augmented randomized complete block design in Agricola package, the function that help to compute it is dau.test function, and the model is followed by the block, then followed by treatment, then followed by y means it is response variable, and here is the method of mean separation. Here is provide LSD as well as Turkey, and also you can specify the level of your significance, either 0.01 or 0.05, and the group is equal to true in order to see the separation groups, and console is equals to false or true, you can say, so as to get the result from the console part. So this is a model. Then the first thing that you have to check is your data. So in order to check your structure, or your data structure, you should have to use str function, then provide your data name. So the block and treatments are factor, but in case if they are not factor, you should have to use this method to convert from what it is into factor. I think you are familiar with this concept. Then we will use attach function so as to remember our data name that we are going to use is AUGG. So we will provide that. Then let's compute the analysis of augmented randomized complete block design using the dau.test function, and followed by block, and followed by treatment, followed by the response variable, and the method that I want to compare among the mean group is the ANOVA significant is the least significant difference, and it's abbreviated as LCD, and group is equal to true, so as to see the mean groups, ABCD letters. So type this and submit to our studio. And for example, if you are only to see the LCD groups or the mean separation groups, you should have to use this code. Or for example, in case if you need the whole ANOVA, just put it this or select AV, then run. So you will get detailed information as you can see here. Yeah, so by this way you can compute you can compute augmented randomized complete block design, and here also the graphs. So if you are not interested about these things, clear this one, then use this code so that you only see the mean groups along with their groups. So for example, among the treatments, treatment J is the mean value is 437.667, and it is the highest, and also it is similar to H. Statistically they are par, but it's different from the rest. So by this way you can compute augmented randomized complete block design. And in case if you are not interested in LCD, you can substitute instead of LCD here TACE. So by this way you can compute augmented complete block design using the Agricola package, more specifically dau.test function. Let's proceed to the second method. The second method is name of the package is augmented RCVD, as you can see here. So what you should have to provide to the R. In case if you haven't, you should have to load this package using install.package, then under quotation write the name of this package. Then the function that help us to compute augmented randomized complex design is the same as the package name. So here is the function, then the model is followed by the block, followed by treatment, followed by the response variable that you have, and again here is the method is the least significance difference, and alpha is 0.05, and group is equal to true, control is equal to true. Control is equal to true means it will display all the results in console path. Otherwise, if you say false, it won't. It will not display the result. So this is the method, the second method using augmented RCBD function using augmented RCBD package. So type this so that you will get all this information. Yeah. And the other, for example, it's obvious in augmented design, you need to specify your checks. Checks means the treatment that found in all blocks, so that if you want to specify, and you can also specify in this way. All things are the same, but what we add from this one is its checks. So checks, then C is subset, then A, B, even the other treatment is found also in the rest, or if A, B, C, D are found in all blocks, so that you can provide it in this way. Then submit to RStudio, then also you get this result. Yeah, so I'm including here is checks, these are the checks. Yeah. Then after, other question asked by my followers is how to generate a genetic variability. So that is very easy. In order to generate the augmented genetic variability of augmented block, augmented randomized complex block design is should have to use GVA. GVA, which stands for genetic variability. Then here is augmented RCBD. It's a function that helps us to generate genetic variability. And AV2 is what we created here. It is a model. So if you provide this, you will get this genetic variability parameters. As you can see, there is genotypic, environment, phenotypic, heritability, persons, genetic advance as percentage of mean, and you can get also this detailed information. This is for the grain yield. And the other thing that I'm going to show you is, for example, if you want to compute, in fact, this thing is not important, is, for example, if you want to run for all multiple traits, so you have to provide, here is augmented RCBD.bulk function, and this is followed by the data name, followed by the block, followed by the treatment, followed by the trait that you are going to analyze. So our aim is to compute a multiple trait analysis. So here is one is grain yield, here is AG, here is pH. Then I also specified the checks, as you can see here. Even you can specify here the check of color if you go to plot the augmented RCBD. So that is the method. Yeah, so you can get detailed information like this. Thank you for watching. Have a nice time.